production have got to get a target. We're not stopping their target, but we've also got it, and that is quality.
Well, I would like to tell you this short story. That I remember a rather prominent visitor to our assembly line some years ago stood at the end of the line, and when asked what he thought of our production line, he said that it's too monotonous to me. He said every vehicle that comes off the line starts at the first pull of the starter button. He said that must be very, very monotonous to your inspectors.
Every Ford car that comes off the Ford production line has got to be a good car, capable of being driven on roads all over the world. That's our task in quality control, to guarantee that every Ford car is as good as we can make it, or better.
Car conditions in the various parts of the world can vary considerably. For example, in Australia, they can meet dust, rutted roads. In Finland, they meet cold temperatures, ice, snow. In Germany, one has to think of high-speed running on the huge autobahns, and all this has to be simulated in our test programs. We are responsible to make sure that the fuel economy of the car is up to standard. Operation-wise, cars have to reach a given target figure. We're always out to try and improve the quality of our vehicles. And braking is one of the things that is constantly being watched.
When we actually get the vehicles, we try them on mud tests, grit and gravel. We leave them to weather in the open air. In fact, we give them a 100% test. I would say that no person in their right mind would treat a vehicle like we do.
Road testing is the last stage in the story of quality control. But the story begins a long time before. It begins with the raw materials.
To get a quality article, you've got to have quality material and quality workmanship. We in the hot metal division start with the raw materials, and by guaranteeing first-class material and high-class processes, we achieve a quality casting.
We have a specified pouring range for the metal, and we use a pyrometer to check that temperature.
To achieve a good quality mold, you must have first-class materials, properly bonded sand, consistently molded. One can't inspect the quality into an article. The quality's got to be in right from the very, very start.
Castings, as they leave the foundry, may look rough and crude to an untrained eye, but they are a precise engineering job. They have to be, because when they leave the foundry, they're going to be worked on by many hundred drills and cutters, all of them preset and automated.
Well, it comes to us, you see, and our first operation is milling. Then we machine like oil pump pads, fuel pump pads, which should be held to within 10 thou. We start drilling bolt holes. Tappet bores, it's got to be within 2 thou. And then we come on to fine boring on the cylinder bores, which has got to be held within 1 thou.
Most people think that in mass production there is rather a hit and miss method of size control. This is not so. In mass production, as we see it at the Ford Motor Company, our gauge tolerances are tied to very close limits. As a result of air gauging, we are now producing 100 times more cars and more accurate than what we would do in the old days when the skilled craftsmen were operating the machines. We used to have a solid go and a not go plug gauge. I think the most prominent part of today's mass production is the introduction of air gauging. We have eliminated the human error.
We check with the gauge against the part and against the blueprint.
We have a minimum amount of gauges on there of about 123. So you can just imagine, on that one shaft alone, we have 123 checks.
Why this emphasis on accuracy? Because that is what the famous Ford service is based on. We can ship any one of our Ford parts to a Ford car anywhere in the world and know that it'll fit when it gets there. In the old days, perhaps you could rely on skilled craftsmen, but today, the modern car industry relies on machinery more accurate than any man could ever hope to be. But even the machines themselves have to be constantly checked.
What we do, we check for tooth profile errors on guillotine. The object to find errors before a shaving operation and after shaving operation, after heat treat and after honing. It's a check that is done 5 an hour in order to keep a check on machine errors in the machine shop.
One of the most amazing modern developments in automation is the process of balancing every single crankshaft for optimum performance before it is fitted into the engine. Previously, this would have been considered possible only for the most expensive individually made cars. Today, it's a common feature of all Ford engines.
I've always been in the motor mechanic side of the trade, and I find that if you do know anything about engines, when you find out the limits which they work to here, you'd be very much surprised. It's incredible that they mass produce to these limits, and we have to keep to them.
from the assembly point of view, each operator is classed as an inspector. Each man whose job is passed on, the next man to him, he is supposed to be ensured that the man in front of his work is done correctly. If it isn't, he automatically rejects it by his own knowledge. Half your inspection work on this job is done by the men on the job. If they find fault, they call you, and you enable yourself to put it right, like, there are more men getting picked out off of the job and getting into these inspection jobs. And they seem to come up and they look towards the inspectors on the job to guide them more than what years ago, an inspector stood on a job watching a man, he'd naturally hop about. As soon as the inspector turned his back, he sort of dodged the column and doing it, that he wouldn't do while the inspector wasn't there. But now, if a man's got any trouble, he's only too willing to shout to say that he's found something. They are more aware of what goes into the product.
All engines, when they've been assembled, are subjected to a half-hour's test where they're placed on a stand and they're driven by a motor. Oil pressures are checked, functional check of the engine is carried out. A check is also carried out to ensure that the correct parts are fitted to the type of engine that has been required.
When the engine has been approved, it is stamped with a number that will stay with it for the rest of the engine's life. Moreover, a daily sample of all engines is put on test for tens of hours to guarantee that no defects have crept in unnoticed. Others are taken at random, stripped right down, and every dimension checked.
The inspector in the Ford Motor Company has quite a lot of power. If a job is wrong, he puts a reject tag on that, a red tag, and that is the law. That tag cannot be removed. Nobody else can remove that tag.
But not all inspection can be carried out by machines. For example, each set of gears is checked for smoother, silent running. Any wrong note and the teeth are trimmed and tested, trimmed and retested until the operator is satisfied.
The job actually is to run the gears, to eliminate damage, find out whether they cause whine, and to eradicate any superfluous damage to ensure a good, quiet gearbox.
This is also true of the transmission assembly.
This is supposed to be the silent house. They make this as quiet as possible. That's their way of helping out here. By listening, sometimes you can feel it if it's very bad. You feel the shock of it going through the old box, but it's mostly by ear.
So it goes on. Quality control, operated by man and machine. Quality control, a control system designed to guarantee the finest workmanship in every vehicle that leaves the Ford works. Of course, we make cars by the thousand. How else can one make cars of quality people expect, at prices they can afford? But we sell them one by one. Every one is as good as we can make it.
Our job is to find faults. That's what we're there for. To find faults and to ensure the men are doing the job correctly.
We take the very first component part that's manufactured, check it completely to the blueprint, and if it's away from specification in any shape or form, we reject the job.
We look for a surface which will provide a finish condition, a finish which sells the car, a finish which is pleasing to the eye, a finish which will weather and give full service to the customer in years to come.
approximately 5,000 spot welds in every car body. 5,000 welds, which are the key to a system producing a car body light and strong.
We find that by properly spaced welds, we get much the same effect as you would get from rather laborious riveting method. Certainly the weld, as far as the method of construction these days is concerned, the welding is probably given us a superior build to that given formerly by rivets, which were spaced at much greater intervals than are the present day monocoque construction jobs welded in this way.
There's a record kept of every gun in the factory. They're going from gun to gun, and over the period of, say, 2 days, every gun in the system's checked.
As in other departments, random samples are taken regularly from the production line and every weld is checked. The occasional failures are communicated to the inspector on the line, whose task it is to see that they are rectified.
Production do rely on us as a check against their standard of work.
The production people themselves are building in quality rather than having to force it into the job.
We have one standard, good quality.
Our job is to provide the paint shop with a body that will give them a satisfactory surface condition for a good application of paint. The body is washed to remove all oil or machining deposits to prepare it for the metal finish operations.
A clean panel enables the operator to examine the surface correctly, find the defects and repair them. And then the body is then passed to the paint shop for painting.
We will be feeling for any high spot, low spot, or anything at all on the face of the panel that would affect the paint.
Each batch of paint is checked by the laboratory in order to see that it's the correct build-up, the correct mix, viscosity, and every day the laboratory are also responsible for checking the system, that the balance of pressure, that the air pressures, the temperatures, the humidity is correct throughout the booths.
What the sprayer aims for is to overlap his spraying on every panel. If you didn't do that, you'd get all kinds of defects, like dry spray, overspray, and all kinds of things like that. But if the fan is that length, well, the idea is to split it halfway so you'd overlap continually. That's to get a nice even flow of the paint.
If quality was to drop, we would obviously lose our markets. We must build in the quality to keep in business. It's part of our job.
Quality is essential, but you must have quality. Well, you can't sell rubbish, can you? Only for a little while.
Well, I mean, it's your livelihood, isn't it? You care about your livelihood, I care about mine. And my children that came after me. I mean, I've got a boy of 15. He's going into technical drawing, I hope, shortly to get him in here.
Before it leaves the paint shop, each body is given careful inspection. It may be rejected, it may be sent back for more work, it may be passed forward. But not even the smallest scratch is allowed to go through without careful repair. And now begins the final miracle of mass production as thousands of separate processes are mated together into a car. Wheels, bodies, engines, transmission assemblies, all are brought together from a dozen different assembly lines, some from different factories altogether, in the right sequence, so that, for example, the right engine meets the right steering. For each car is an individually tailored item built to a centrally planned specification.
99% of our production is balanced. All the information is put onto a build-up sheet. Now we follow that build-up sheet right through from the time it leaves the paint to the time it gets into what we call our selling area.
Our whole system is broken down into zones. Each zone is manned by an inspector. Now, the inspector has a responsibility of covering the operations from the inspection aspect, covering every production operation within his zone to see that it is adequately done, correctly done, and if necessary, he'll write up anything that is defective, and he is in close attendance with a repairman who puts the job right in its zone. 32 inspectors are inspecting each vehicle in process through its journey through the assembly plant. Now, to enlarge on the in-process inspection technique that we use throughout this assembly plant, the in-process inspection ensures that if there's a fall down on any one operation, it is at least caught and rectified in the shortest possible time. We favor the in-process inspection for this very reason. Were it not for the fact that we had in-process inspection, we should miss the opportunity of checking back on an awful lot of work because we'll miss built-in items. Let's take a door, for instance. You build into a door lock, a remote control, a window winder, a glass runner, and then we go and put a door pad over the top of it, and we put the handles on. Well, were it not for the fact that we had in-process inspection, the whole of your internal assembly of the door and the functional items that go into it would be lost forever. We wouldn't know whether the operator had fixed the remote control with one screw or the requisite 3 screws, or we wouldn't know whether he'd fitted spring washers under his screws or not.
The inspector will check the build-up. He will check to a specified list of assembly parts, that they go together correctly, that the quality is built into the car. When the car passes to the next stage, the inspector will then check anything that the previous inspector has found to ensure that the repair has been done satisfactorily.
There are final inspectors whose responsibility is to see that nothing has happened to that job from the time it has left the paint shop until the time it arrives at his station. The final inspector would ensure that all the previous zonal inspection stamps are on the check sheet, and he will then ignore all those stamps and treat that vehicle as though it is a customer approach vehicle. In other words, he will go through the whole series again, what all previous inspectors have checked. The final inspector has the last word on what is built-in quality.
This is the guarantee every Ford driver has. From the first raw materials to the final trim, everything has been tested strictly and relentlessly. Functional items are subjected to destruction tests, extending far beyond the life of a normal car. Weatherproofing? Vehicles are exposed to 4 inches of rainfall in 4 minutes, 250 gallons of water. Safety. Every factor affecting life and limb has been tested 100%. Brakes, steering, lights, every car goes on the roller test before it leaves the assembly line. Then onto the final acceptance area. Every detail is rigorously checked and checked again. The car is ready for sale to the customer. For this is the story of quality control. Quality that has been built into the car from the very start. Remember, we build it in, from first to last.